All right. Good morning. So we are going to have this next lesson is going to be on permutations and combinations. Basically, in a nutshell, a permutation and combination are basically ways of grouping things. A permutation is a way in which the order matters, and a combination is a way in which the order doesn't matter. Okay, so a combination can be anything. Permutation is a specific way, right? So we'll kind of talk about those. There's a lot to this lesson. So I'm going to jump right in and going to full disclosure that I myself struggle with understanding quite a bit of this and like keeping it straight. Like I know how to do the math, but like setting it up for me is a struggle sometimes. So I get it if this is kind of complicated for you. So I'm going to teach it to you, and we're going to learn it together. So we're going to start with erasing this mess I just made, and then we're going to jump into the fundamental counting principle. All right, so here we go. So what the fundamental counting principle is this kind of this like general way that when you're figuring out like how many ways something can happen, right, with a certain number of things, it can really be like wild, right? So it's pretty easy when you say to yourself, okay, um, if you have two things, how many ways can you order them, right? So you'd say, well, if I have thing A and thing B, that's easy. You can order it like AB, and you can order it as BA, right? So if you have A and B. Now let's say I have A, B, and C. Well, I can order the ABC, right, and ACB, and then I can start with B instead and go BAC, and then BCA, and then you can go C, AB, and CBA, right? So you go from 2 to 6, and then when you go up to 4, all right, that's when it starts to get really crazy, right? So you get, just go right in order A, B, C, D, and then you go A, B, D, C, all right, and then A. So those are the different ways, and then we can switch, C around here and go A, C, B, D, A, C, D, B, and then you go A, D, BC and ADCB, and all I'm doing is just kind of doing different orders of these, all right? And so I did all of these are just ways I organized A, right? And now if I do B, you'll see that I have the same thing. I can do ACD, I can do BADC, and then I can move C to the front and go CAD, BCDA. Remember, the order is important, so there is a difference between AD and DA. And then BD, and then AC, BD, CA. So hopefully I don't have to keep going. You can see that there's going to be another 6 for C and another 6 for D, right? So for the C starting, you'll have 6, and for D, you'll have 6 of them, right? So this is 6 times 4, which is 24. This one was 3 times 2, right? Which was 3 times 2 is 6, and this was 2 times 1, right? Which is 2. So it's kind of like there is this thing going on, right? And so the way it works is when they tell you this, right? They would say, all right, how many different ways can you order A and B? And so right? And two different ways. So you do that. So what we do with the fundamental counting principle is you take things and you multiply them together, right? How many different ways it can happen, right? So a bicycle, so let's look at this example. We got a bicycle manufacturer makes 21 and 24 speed bikes. So how many kinds of bikes does he make, right? Types, right? Types of bikes, he makes 2, right? In 7 different colors. So the colors, right? So there's 7 colors and 4 different frame sizes, right? Sizes. Let me say 4. Okay. How many different bicycles does the manufacturer make? And so this is, obviously a case in which, you have to figure this out. So you'd say, oh, well, it's 2 times 7 times 4, right? Um, so in this case, you would just kind of multiply these all together. You go 2 times 7 is 14, and 14 times 4 is going to give you 56. So you have 14 times 4, not 16, 14. 14, write it correctly, equals 56 different bicycles. All right, that's the number of options. And if you're ever questioning this, you can always like start writing it out, and you'll be kind of like, oh, it'll it'll come into focus really, really quickly, right? So I think that I think that this is a good thing, all right, for us to know how to do, and yeah, and then that's how that works, all right. So this is the fundamental counting principle, um, and it's something we're going to use this idea and this concept throughout probability, and you will always see this, and it's basically whenever anybody says you've got, the classic example is there are 2 shirt tops and 3 pairs of pants and 4 pairs of shoes. How many different combinations, right, can you wear? And so then it's just a matter of, all right, go 2 times 3 times 4, right? And so then you would be like, oh, there are 24 different combinations of what you can wear, right? Um, so these are kind of fun and they're interesting. What's nice about them is in smaller doses, you can kind of check yourself and see if it worked. Because if you didn't trust this answer, like I said, you could be like, okay, we're going to make, we got a 21 speed bike and we got a color 1, and then there's 4 different frame sizes. So you got extra small, small, medium and large, right? And so you could say, okay, and 1, 2, 3, 4, 5, 6, 7 for your colors. And so you can see 21, 1, extra small, 21, 2, extra small, 20. You could go through that and list that out, and it will help you to see that, oh yeah, we're leading towards this 56, so I can just multiply these all together and we're good. All right, so hope that makes sense. We'll see you in the next one when we start talking about permutations.